Hello everyone. So today we will see how we can use Modbus TCP/IP protocol to communicate between ACS880 drive and AC500 PLC. So this is my setup for the ACS880. So I'm utilizing the slot one where I have put this FENA21 card which supports Ethernet, Profinet and Modbus. Okay, so I'll be utilizing this card for communication with the PLC. So I have put the Ethernet cable here and it's directly connected to my PLC, uh, which is just the PLC without any external modules or anything. It's directly communicating with this Ethernet port. So the advantage is that you don't need an like a Profibus adapter or a Profinet adapter to communicate with the drive and control the drive. I'm just utilizing this port. Okay, so let's see how we do it. And so the drive side, uh, you need to do the basic setting, like you need to enable the, since I'm using the slot one, you enable FBA enable and show which port you're using. So I'm using slot 1, and the reference type you can keep it auto, so the drive will decide which reference it is in speed or torque. And this is where you put the important settings, like uh, the type of the card is Ethernet, and here is the main part. So here you'll find a lot of options here. So I'm using Modbus TCP/IP ABB enhanced. E means enhanced. This is the protocol I'm going to use. Com rate, you can keep it auto, and here you define what is the IP address of your drive. So I had defined 192.168.186. Okay, the subnet, if you put 24, it means 255.255.255.0. So this explanation for this you can find in the manual, and I put the same IP for the gateway. Okay, and all this you can keep it as default. Okay, and this one, the work order means if you are using 32-bit data type, the first high low means the first the high MSB and LSB. The MSB will go to the first word and the LSB will go to the second word, and all this you can keep it as default. Okay, and you make all the changes and you click refresh, so that these parameters will go into the drive. Okay, so this is the basic setting for the Modbus communication for your drive. Okay, and this is for the data in and data out. Data in means the words or the data that you are going to read from the drive. So here I configured status word, then actual, which is the if your drive is running in speed control, the actual means this will be the speed feedback, okay, from the drive. And 1.11, this is the 1.11 means 1 is the actual value. 1.11, this is the DC bus voltage, and 10 is the torque, then 7 is the motor current, and 3 is motor speed. Okay, this depends on your requirement. Whichever data you want to read from the drive, you can use this and configure. Okay, so I'm going to read actual speed, then DC bus, torque, current, etc. And data out means the PLC, uh, from the PLC to the drive. So the first word will be the control word, and second word will be the speed reference. This is not required. Okay, so these two are the words that we are going to send from the PLC. So this is the basic parameter setting, and here this is the basic things, like how you are going to stop the drive. So the start drive is from field bus A, which is the from the the FENA card. Okay, and you need to define the start stop, sorry, speed reference. You can define FBA reference one, means it takes the speed reference from the field bus A, that is from the slot 1. Okay, so this is the basic setting required the drive side. If you need more information, you can find many videos in my channel explaining all this, the drive setup. Okay, so the PLC side. So as I told you, I have a PM 573 PLC, which is just the PLC, nothing else in this. So I have configured the same thing. I have added the PLC here. Then if you go onto Ethernet, you will find the protocols where you can right click and click add object, and you can click the Modbus TCP IP server. Okay, the server setting is this all. I have not changed anything, it's all default. And here you need to mention M or R. The only difference is if you put R, it will be retained, the value will be retained. So it's okay to use the M area, memory area. So go to the program. Okay, so this is the basic program for reading and writing the value. So this part I have fully explained this blocks, how you need to configure everything in my previous video. I'll put a link in the description, so you can see that video to get a complete explanation for this reading and writing to the using the Modbus protocol. Okay, so I'll explain the basic things. So we need to define the slave IP. Slave IP is nothing but the I'm calling it slave because for me the master is the PLC and slave is my drive. Okay, so here you need to enter. I am configuring slave IP as string. So here we will enter the IP address of the drive, which is 192.168.186, which is the one you configured already. And this is important. If you're reading the drive, the function code should be 3. Okay, and this part I will explain. And similarly, so if you put 3 means I'm going to read something from the drive, and if you put function code as 16 means I can write multiple words to the drive. So the explanation is like, so if you go to see the FCT code, okay, 3 means I can read multiple words from the drive, 16 means I can write multiple words to the drive or the whatever is your slave. Okay, so this basically explains how we are going to read and write. So now this part, this is the starting address from where I'm going to read from the drive, and this is the number of words I'm going to read from the drive. Similarly, this is the starting address where I'm going to write to the drive and how many words I'm going to read, how many words I'm going to write. So the explanation for this you can find in, if you download the FENA manual from ABB website, you will find all this. Okay, so the protocol that we are using is Modbus TCP IP. Yeah, so let's click on this, and I'm using as I told you in the setting, I'm using Modbus TCP IP ABB enhanced. So we will use this. So as you can see, these are the Modbus registers. You don't need to worry about this 4, because when I select this function code as 3 and 16 automatically takes the Modbus register 4. And okay, where is it? Yeah, and you can see it start from 51, but you need to minus 1, so it start from 50. uh, 50, so the address Modbus register 50 will hold the status word, and 50 uh, 52 you will hold the this one, the speed feedback, and uh, torque. So the actual one will be the speed feedback, and actual 2 will be your torque. Okay. And this one, from next data in 1, data in 2, this is where we are configuring these things. Okay, so in 1, in 2 we already configured it as status word and speed actual, which is already defined, you know. So you are getting status word, status 2, actual 2. So this one you don't need to configure in the PLC, because this is already we are getting from address 50, 51 and 52. And data, so you need to start declaring from in 3, in 4, in 5. So here I have configured in 3 as DC bus voltage, torque, current and motor speed. Okay, so you will understand once we configure in the program. So all you need to understand right now is we are going to read the value from 50. Okay, so this is what you are going to do in the program. So you need to define the starting address as 50. Okay, and number of data, so I am going to, if you count it, we are almost reading 15 values, so I just put 15. And here you need to define from where you are going to read. Okay, so what we can do is we can define an array. Okay, so I defined an array which start from 0.50, that is our register address, and I have declared 15 values of word. Okay, so you can put this here. Okay, similarly I have to send some value, and for sending, as you can see in the manual, it starts from address 0. Okay, like 1 2 3 like this. So what you can do is you can define the same thing, like so I don't need to write much, so I just put some 10 values. That's why I put 10 here. Okay, so this array means it is going to write a value from memory word 0 to 10, but we are only writing like control word and speed reference. That is enough. So I am just writing only 2 words, but I just declared 10 anyway for the future if you want to use. So you can copy this here. Okay, so now I'll download. So my PLC is 82 and address is 82, so I download and it's running. So you can see it's already communicating with the drive. I don't have any error or anything like that. So make sure the drive is configured this before doing in the PLC. Okay, so now as I said, if you go to the slave data is something that you are receiving from the drive. You can already see I am getting already some values here. So the first, if you refer the manual, okay. So if you refer the manual, we are reading from 50, okay, which is the status word, and this will be the sorry. So the second will be the actual speed, third will be the actual torque, okay. So data in 1, in 2 we are not touching. So these two you will not get anything in the in the Modbus register. So you will start getting values from in 3, in 3 onwards, in 3, in 4, in 5. So you can check what you configured in 3. In 3 is your DC bus voltage, which is what I am getting here, DC bus voltage. And I will get, once the motor start, I'll start getting these values, that is the torque, then current. So I'll get torque here, current here, and motor speed here. It depends on what you declare here. So whatever you declare, you get the value here. So as you can see, if you see the DC bus voltage, it is 573 point something. So if I divide this by 10, I'll get the DC bus voltage. And send data, okay. So send data, you need to write a program for this. So as I said, my first that is slave data, the first word in the array is my status word, and the second word in the array is my speed feedback. So let's decode all this in the program, okay. So I'll declare a global variable. Let's call ABB. So this is the status word, SWABB. This is my control word. Speed feedback, which I'll configure as an integer, and so let this be integers. We will configure later, okay. So now let's define one more program. Like I already predefined this drive, or you can give any name, okay, but you need to call this. If you are using this separate program, you need to call, because this is the one PLC PRG, this is the one that PLC is going to execute first. So let's call this one. Okay, so I call this block here. So now this program will be executed. So I predefined some variables here, which is nothing but yeah. So if you go to the no Profinet, okay. So this is the status word explanation. Now this is a control word. So this is the status word. So you can see that the first bit of the status word means ready on, second bit means ready run, okay. So I will configure this. So what we can do is we will move this slave data, that is the first word of slave data, to the variable that I declared. So slave data. Okay, so what I did is the first word of the slave data I moved to SWABB, and similarly I'm going to write something from PLC to first word of this one, send slave data. Okay, so now I moved this one to the SWABB, and I will be writing from CWABB. Okay, so now let's decode this. So I'll put this here. I already prepared this. So this means what? So SWABB is where we already moved the status word to this variable. So I will use this variable. The SWABB dot 0 means the first bit of the status word. The first bit of the status word is what? Ready on. Second bit is ready run. Okay. So I declared everything here. So let's log in. What happened? Some error. Okay. So as you can see, I am already getting some values from the status word. It's in remote. There is some alarm, so I have to do a reset. Okay. Now let's copy paste the control word. Okay, so this means that this explanation, you can find the control word. So I'll be using the first bit of the control word to start the drive. The second bit should be true, third should be true. All this I have explained in my previous video. You can have a look. And basically you need to concentrate on these bits. The first bit is the start bit, and this is to reset the fault. Okay, it should be in remote. All this blah 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 I have explained a lot of times. You can see in my previous videos. Okay, so let's reset if there is some faults or something. So if I give a start command right now, the drive should start. Yes, the drive started. Okay, now let's configure. You need to give the speed feedback and speed reference. I will better do it here. This is the status word. Now speed feedback. So the speed feedback comes from slave data, second word of the slave data. Okay, so you need to divide. No, you need to convert this to integer. Convert this. Okay, so the slave data is in word, so I'll convert the word to integer, divide by 200, and we already declared this speed feedback. Let's quickly paste that. Okay, now I have to give the speed reference. So let's use the command word. Okay, so the speed reference I will give from global variable. So this time you have to multiply by 200 because I'm giving it in percentage. And I'm going to directly write to slave data. Sorry. Sorry, I have to do that before here. Okay, so the speed feedback I'm getting from here, this is not required. Okay, I'm directly converting to integer. Divide, I have to divide by 200. Okay, to get the value in percentage. Okay, so this will be an integer. Now if I begin the speed reference from here, so speed reference is again integer, so I have to multiply by 200 to convert from percentage to speed. Then I am converting back to word and sending to the second word of the send data. So let's log in. Okay, now let's give a start command. Okay, the drive has started, it's waiting for the speed reference. So let's give like 50% speed. Wait, something is not correct. I'll just reset once. Okay, let's try again. Yeah, it's running. Yeah, so if I give 50%, I'm getting 50 as feedback. So if I give 80%, the motor will jump to 80. Now if I give negative 80, So the motor reverses the direction. You can see the motor speed here. This motor is 1400 rpm, so if I give 50% it will run at 700. If I give 100% it will run at around 1400 rpm. So let's give 100% speed. So motor is running around 100%. It's running at 93 only. So that's it. So this is how we do the okay. I have not done the ID run for this, that's why it's not going to 100%. So this is how we do the program for Modbus communication. So let's stop. So I hope this was clear for everyone. So thanks for watching this video again, and thanks for all your support. So have a good day. Thank you.